Okay, this is really a video for lesson 11.3 and 11.4. There's only one difference between the two lessons. 11.3, the coefficients are ones in a lot of the variables, and 11.4 you have to multiply. So I'm going to try to demonstrate the difference in these with an example as I go through, and then we'll just keep going with the lesson. So I'm going to come down here. So in 11.3, an example of a system that you might see would be, I don't know, something like 6x minus 3y equals 15, and 4x minus 3y equals negative 5. So in this case, when you're doing what's called elimination, you're trying to eliminate a variable. So in this case, we want to eliminate the y's. Why? Because they have the same coefficient. The problem is one's a negative, the other is a negative. To get rid of them, they have to be opposite. So the first lesson is about subtraction. Well, we never talk about subtracting. There's only adding the opposite. So all that means is what you're really doing is multiplying everything by a negative, which goes through and changes the signs. Now, what happens? These now cancel. They're opposites, they go away. So if you continue with the problem, combine 6x and negative 4x, you get 2x. Combine 15 and 5, and now you get 20. Divide by 2, now you get x is 10. Now, how do you find the y? All you do is take that and plug it back into one of the original equations. I usually just pick the top one. So you have 6 times 10 minus 3y equals 15. Now you work this out to solve for y. So you get negative 3y is negative 45. You divide by negative 3, and now you get y is 15. So that's lesson 11.3. Now sometimes the variables here are already opposite, so all you do is just combine them and they cancel out. But if they're not, if they're the same sign, then you have to multiply by negative, or the book describes it as subtracting. This lesson is exactly the same thing, except you have to multiply by things other than a negative 1. You may have to multiply both equations or one equation. So that's what we're going to do here. So again, they give you an example here of how to change the systems and how it becomes a new one, and then combining and do. I'm going to skip right to looking at the your turn. Again, they give you instructions or steps on how to do this, which are not bad to look at and refer. So here's an example completely worked out, one fill, and then we have a your turn. Now, why are they giving you a graph? Because they want you to always check your answers. So I'm going to do number 4 with you, and then I'm going to have you do number 5 and then check it. So in number 4, first thing we have to do is decide which variable to get rid of, x or y. Well, in this case, I'm going to get rid of the x, and the reason I'm going to get rid of the x is because one's already negative and the other's positive. Now, here's a very easy way to do these, kind of a shortcut kind of thing. How can I get rid of the x in the two equations? Well, what I'm going to do is I'm going to take the top equation and multiply it by 2. Why 2? Because 2 is the coefficient in the bottom equation. I'm going to take the bottom equation and I'm going to multiply it by 3. Why 3? Because 3 was in the top equation. I don't worry about signs here because one's negative, one's positive. Now, if they were both positive, then I would have multiplied one of these by negative. So I do distributive property. When I do that, this equation now becomes negative 6x plus 8y equals 24. Make sure you multiply it times all the terms. Multiply here, I get 6x plus 3y equals negative 24. So now what happens? Well, if you look right here, what about my x's? One's a negative 6, one's a positive. What's going to happen? Those are now going to be eliminated or cancel. Combine my y's, positive 8, positive 3 is positive 11. Then over here I get 24 and negative 24. What happens? They cancel. But that still leaves a numeric value of 0. divide by 11, and you just get y is 0. Now, how do you get x? Go back and plug it into an equation. Which one? Well, in this case, I'm just going to pick that one. So I have 2x plus y now is 0 is negative 8. So I have, 2x equals negative 8, divide by 2, and I get x is negative 4. So again, what you could do is take each equation and graph it. Now, how would you graph it? You could graph it by doing the intercepts, or you could graph it by putting them in slope-intercept form and then putting them on the calculator. So what I'm going to do is do the intercepts. So in the first equation, get rid of my x. That means y is 3. So I go up here to 3 and put a point. Then get rid of my y, divide by negative 3, so x is negative 4. And then I draw that line. Second equation, get rid of my x, y is negative 8. So I go down, now I have an issue with negative 8. Why? Because it doesn't show up on the graph. Well, let's go ahead and see if we can get the x-intercept. Divide by 2, I get negative 4. Well, negative 4 works. Well, lo and behold, it's the same point as I had on the other one. So that other line would graph something kind of like this, since it went down to negative 8, and they intersect here, which is at the point negative 4, 0, which is what we got right here. So what I would like for you to do is go ahead and try number 5. Pause the video if you need to, and then I'll put the answer up and you can check. Okay, so in this case I wanted to get rid of my y's because one was positive, the other was negative, so I multiplied the top one by 2, since that was the coefficient in the bottom equation, multiplied the top equation, or the bottom equation, by 3, because that was the coefficient in the top equation. Do distributive, the y's now cancel or eliminate. Solve for x, get x is negative 2. I plug that back into the bottom equation here. Plugged it in for x. Work this out. Got y was 1. Now, graphically, that means it should be intersect at the point negative 2, 1. So I'm going to mark that here. So now what I'm going to do is try and graph the two lines and see what happens. So let's take the first equation. If I get rid of my x here, divide by y, or by 3, I get a negative 1/3. Well, that's not very convenient. That doesn't help me very much. So graphing and checking is sometimes more difficult than it's worth. So how would I check? I would just actually take the point and plug them in the equation. So negative 2 in for x, that gives me negative 4. 1 here is 3, negative 4 plus 3 is negative 1. Negative 2 here is negative 10, and negative 2, negative 10, and negative 2 is negative 12. And much quicker. So graphing is a method, but again, if you're not putting them in slope-intercept form, maybe not always the best method. So again, they give you one using a word problem. So go to your turn, look again at the equations, decide which variable you want to get rid of. So I'm going to rewrite the equations over here. So in this case, it really doesn't matter which one, because they're all positive. But in this one, I'm going to go ahead and get rid of the a. So I'm going to multiply this one by 3, because 3 was down here. And I'm going to multiply this one by 4, because 4 was up here. Now, since they are both positive, I need to multiply one of these by negative. So I'm going to multiply the bottom one by negative 4. So you do your distributive, and you get 12a plus 6s equals, now these start to get a little big, but that's 192. Multiply the bottom one, negative 12a, which is what I wanted to happen. I wanted those to be opposites, minus 12s equals negative 240. So again, those are going to eliminate or cancel. I get negative 6s equals, now combine here and you get a negative 48. Divide by negative 6, s is 8. Now to get a, what I do, go back and plug into one of the equations. I'm just going to plug into this one. So I have 3a plus 3 times 8 now equals 60. So 3a plus 24 equals 60. Subtract 24. Oops. So I get 3a is 36, divide by 3, and I get a is 12. Now, let's go back and read what the question asks for. It says where A is the cost of an adult ticket, S is the cost of a student ticket. How much does each cost? So an adult ticket costs you $12. A student ticket would cost you $8. Word problem, always read the context and know your answer. So on this, you're doing page 521 for 11.4. Now, actually, what you want to do is you want to go back and do 11.3 also. So 11.3 was on page 509. And on that page, you're doing 3 through 23 odd. And then for 11.4, is what I just showed you on page 521, you are doing numbers 1 through 21 odd. So we're combining these lessons because they're basically exactly the same.